Okay. Now I'm going to compare the parallel circuit and the series circuit um, using examples. Well, what I do is I connect three globes. Okay. So I just made up this symbol. Okay, I call it a globe. Okay. Now I have three globes connect in series. Okay. And each globe has maybe 1,000 ohms resistance. Yep. Okay. And I'm going to draw one. Um, draw three globes connect in parallel. Now, okay. In series circuit, okay, we have three globes connected in series. Okay. So what's happened is the voltage of each globe, the voltage are divided. Okay. So I have 4 volts here, 4 volts here, and 4 volts here. Okay. Now, in a parallel circuit, the voltage will be the same. Okay. The voltage will be the same. Okay. Now, let's have a look at the current. Okay. The current in a series circuit, okay, will be um, the same, which is uh, can be found by the total voltage divided by the equivalent resistance, which is 12, okay, divided by 3000. Okay. So it's going to be 0.004 amps. Okay. However, in here, okay, in parallel, so what's happened is um, now, okay, because the resistance is still the same. Okay, so what's happening is we're going to have 0.004 amps, okay, of current across in each of the globe. Okay, so totally, okay, the total current, okay, will be 0.012 amps, three times as the circuit board. Sorry, as the series circuit. So what is going to be happening is, okay, the globes the globes compare with in series compare with in parallel will appear dimmer. Okay. Now in here it will be brighter. Okay. As a result, if you can see, because we use more current, okay, well, at the power supply is the same. It's 12 volt. However, okay, in parallel circuit, we use more current from the power supply. Okay. So what does it mean is the three globes connect in parallel draws more energy, okay, draws more power. Okay. So remember, energy is measured in joules. Okay. Power is measured in watts. Okay. Means joules per second. Okay. So uh, if we if I try to calculate, okay, the power equals to Vi, okay, or I square R, okay, now or V square R. Okay, so if you're going to calculate the power from the power source, okay, now you're able to find. Okay, so we need to use the total current, okay, because I'm trying to find, okay, this. Okay, now it's going to be 0.144 watts. Okay, now from here, okay, the current, the power will be 0.004 times 12, okay, will be 0.088 watts. Sorry, 48. The power is 3 times larger. Okay, so in parallel, they become brighter. They use 3 times more power. Okay. Now, yep, this is the difference. Okay. Because the current is low here, so it's dimmer. Okay. Now, um, okay. Now, okay. Now let me show you couple of different ways of drawing parallel circuits. The idea is you need to be able to uh, find them out. Okay. Here are four circuits. Okay. Now, and if you look at them, okay, they all have three resistors. They all have the same resistors in the circuit. And let's look at the first one. Okay. Now, what's happening here is I have a resistor, and the resistor is connected to in parallel with another resistor. Okay. Now, if you look at the other one, these two are the same. Okay, they are the same because same thing I have because current flows here. Okay, the current flows there, and when it reaches this junction, it breaks up. Okay, then they come together. Okay, to two resistors, so they're just the same thing. Okay. However, if you look at this one, this one here, okay, is more confusing. Okay. It looks more confusing, but actually it's the same as uh, the circuit board is the same as the previous ones. So if you analyze it, we have current coming from the positive, okay, go through the wire. It meets one resistance, okay, similar to this one. It meets and go across a resistance, then it splits up. Okay, then it splits up to the other two resistance. Okay, then the current meet together. Then the current meet together. Okay, and together they go to the negative terminal. Okay. Similar with the previous ones, this one is also the same. I created four uh, electrical circuit, four of the same electric circuit in a different drawing. Okay. So similarly, say I have a current come to the first resistor, then it leaves the first resistor, then it goes to two other resistor, then they combine, go to the negative terminal. So they all the same. So sometimes you look at your notes, you'll see all these confusing pictures of resistors arranged in shapes, triangles, in squares. And if you do the analyze, you can easily break them into the simplest form, look like that. Okay, then we can analyze it. Okay, I will analyze this kind of circuit in an example. Okay? Um, so just remember, we can draw them. These four are the same thing. Okay, we can draw them differently. So in the exam or in the test, also in year 12, what you need to do is you need to be able to recognize all those okay, circuits. You need to be reconstruct them into the simplest one. Okay. Now,